One will be introduced by Jenny Zhang.
Thank you, Jennifer, for the introduction. So good morning, everyone. My name is Jenny Zhang. I'm very excited to be here today to share our work title as IEA-Plot, Conducting Wafer-Based Data Analytics Through Chats. So before getting started, I want to acknowledge my co-authors, Matthew Dupree and Mingjian Yang over there for their contributions in this work. Now I'll give a demo of using the IEA-Plot to provide you more concrete examples. Okay. So let me open my web browser and go to our IEA web app. So on the left-hand side here is the dialog box where we can type in the queries. So let's say I want to investigate the wafer probe data for a certain product, and I want to start by seeing the yield loss in a time period. So I'm going to type in, show me the yield loss in wafer probe for product ABC. That's just some random name for demo purpose. So IEA processed this query on the fly, and that process including extracting the corresponding subgraph and calling the backend API to grab the data. And the result is a scatter plot like this. And I can zoom in and zoom back to see the data. So now suppose I want to see the average yield loss per lot over time. So I can type in the query, show me the law by law yield loss instead. And hit enter. So every time I enter a new query, the result from the previous query will always be kept on the far right for reference. And all the queries we've done up to this point will be tracking the top history bar over there. So let's keep going. Let's see how many wafer maps are in this data set. So simply show me the wafer maps. And we can see there are about 13,000 wafers. So next, let's do something interesting. Let's try to find some patterns in this data set. So please list all the patterns in this data set. And this time, IR response is like, I don't find any particular patterns here, but IR shows us a histogram of how the number of failures is distributed across the test bin groups. So we can see there are 3 soft bins highlighted as having the most failures. And I think that's a good idea. Let's see if we can find pattern based on the top failure bins. So show me those in top 3. Now, I found 7 types of patterns, including arc, ring, donut, etc. And if we take a look, most of them come from bin 40 and bin 41. So let's say I want to take a closer look at the arc patterns. So I'm going to ask how many different arc patterns do we have? So now IEA shows 3 options of the arc patterns. The clock direction, that's where an arc is located on the wafer edge, and the arc length and arc thickness. So let's see all of the 11 o'clock arcs. Let's focus on the wafer maps patterns at 11 o'clock direction. So as you can see, we have these many arcs that all satisfy the 11 o'clock description. And there are actually 3 groups, as we've mentioned before, and their order is based on how obvious the pattern is, which is determined by the media analytic module. So next, let me see which lots they are in. And then let's just focus on February. And we can pick one lot that's having the most 11 o'clock arcs. So that's this one, 200Q7U. And so I want to see what it looks like in the slots. Yeah, so as we can see here, this law indeed has some sort of systematic failures at the 11 o'clock wafer edge. So, okay, now I'm gonna switch to see another pattern type. Let me see the options for donut pattern. So there's just one option, that's the thickness. How about the centers? Let's take a look. And we can see we have some solid centers based on the density and also some massive or medium-sized centers. And for each type of the pattern, we can repeat what we've done for the arcs like before. So now I want to go back to the 11 o'clock patterns I found. To do this, I can click on one of the cards in the history bar to retrieve the result from the specific query we've done before. And in this case, I'm clicking on 6. Okay, so now we are seeing all the 11 o'clock patterns again. I'm wondering if there's a correlation between these patterns and some e-test values. So I'm asking IEA, please correlate this pattern to e-test. It takes a while for analyzing the correlation because IEA needs to search for the e-test that indicates the most correlation to this pattern. Okay, so now IEA gives a scatter plot where the axes are the 2 testing sites, and the arc pattern highlighted in red are all concentrated in the top right corner among all the other wafers in this data set. So I want to generate a trend line plot for the e-test and see how the corresponding lots are distributed in the plots. So show me the trend plots of this. Now, each dot here is a lot, and the y-axis is the average e-test value of a lot, and the orange line is a regression fit of the e-test values. We can see the red dots, which are the 4 lots containing all the arc patterns. They are all located on the top of the distribution. So now I want to show you something. If we click on the history tree here, we can see how each query we've done, they progress one step down from the very beginning. And except for that, we opened up a new branch here to do the e-test correlation from query 6. And this is actually a summary of the analytics we've done just now. So before we end the demo, let me show you a little peek into our internal knowledge graph process. So every time we enter a query like this, like we said, we'll activate some nodes in the knowledge graph. Those are the red nodes here. And we did it by match the intent and the phrases. And based on those red nodes, we can extract the connected subgraph like this. And again, the subgraph corresponds to a configuration to call all the backend API functions to get the result we've seen before. And if we enter a second query, let's say show me the patterns. And it will do the similar process and we will get a new set of nodes. And this is another subgraph, and which is a new configuration. And the orange nodes here are the ones overlapping with the previous graph. So their associated objects can be carried over, like transferred to this stage, like we mentioned in the context switching. And we can also see this intent here is about pattern analytic intent. Okay, so that's it for the demo. Let me go back to the presentation.